In this video, you can see I kick this ball vertically straight up into the air. Now, do you think this ball will return to my foot at the exact same speed at which it left? A slower speed or a faster speed? In an ideal environment, it will return to my foot at the exact same speed at which it left. But before we go on, if you're interested in football and want to watch more on it, please check out my other YouTube channel. The link will be in the description. One of the most important laws of physics is that energy cannot be created or destroyed. So when I'm here with my football, basically on the ground, and I kick it, I am giving it some speed, some velocity upwards, and therefore we know that the energy related to being with speed is kinetic energy. I'm giving it some kinetic energy. So it then goes up into the air, and you know that it stops. At this point, all the kinetic energy has been converted into gravitational potential energy. So it's no longer moving, and gravitational potential energy is associated with how high above the surface of the Earth a football or an object is. So it slows down because it's losing kinetic energy, and that kinetic energy is being transformed or converted into gravitational potential energy. It's not getting destroyed, it's only being converted from one form to another. Now, due to gravity, this ball is going to start falling down again, and it accelerates downwards. And all this GPE is converted back into kinetic energy. And since energy is not created nor destroyed, the initial kinetic energy, called that KEI, is equal to the gravitational potential energy, which is also equal to the final kinetic energy. And therefore, the speed at which it left my foot is equal to the speed at which it comes back. Now, in a real life scenario, it will actually be a little bit slower because some of the energy, initial kinetic energy, would have been converted to heat energy due to the air resistive force. Now let's look at some equations that you'll probably have to know for your exam. So let's start off with gravitational potential energy. GPE is equal to mgh, formula you may already know, where m is the mass in kilograms, g is gravitational field strength. Use a value of 9.81 in your exams unless it wants you to carry g throughout the equation. This is gravitational field strength. This could either be meters per second squared or newtons per kilogram. Both are the same. H is your height above the surface in meters. The other big equation is your kinetic energy, which is a half mv squared, where m is your mass in kilograms, v is your speed in meters per second squared, meters per second. And the last equation, which you may not always see that often, is your elastic potential energy, which is a half kx squared, where k is your spring constant and x is the extension. Spring constant is in newtons per meter and the extension is in meters. Your power equation, which we covered in the electricity topic module, is equal to energy over time. Power is the time derivative of energy, and the power is given in watts, energy is in joules, time is in seconds. Now, if you're dragging an object with a force along a distance d, the work done on the object is force times distance, where F is your force in newtons, d is the distance travelled in meters. And we know that power is the time derivative of force, so basically you're dividing by time. So if you do work done over time, you'll get power equals force, and you know that distance over time is velocity, so you also get power is equal to force times velocity. But F is your force in newtons and v is your velocity in meters per second. The best way to memorize these equations is by just doing a lot of practice. So I advise you go and do some past papers after the end of this video, or just any topic questions, and rinse and repeat until you're very comfortable with using these equations. Now, if we look at the first scenario, and I have this ball on the ground, I'm kicking it with speed v, and it's going to reach this height h, where it stops moving. I want to find out what height does it stop moving, and there's two ways to do this. The first way is by using SUVAT, which is in my previous video. If you've already seen it, go have a go and calculate what this height is and using these variables. There's also another way to do it, which is by setting energy equal to each other. So it starts with kinetic energy here, and you know it ends up with only gravitational potential energy. So you can say that the final gravitational potential energy is equal to the kinetic energy at the start, which means that mgh is equal to half mv squared. You can see that the masses cancel, which automatically lets you know that the mass of an object, the height at which this object reaches, is independent of the mass. The mass does no effect on how high this object can go. So if you rearrange to work out what the height is, you get height is equal to v squared over 2g, which would be the same as if you tried using your SUVAT equations. Now, this is assuming that there are no resistive forces at play here. If there were a resistive force, your initial kinetic energy would be equal to the gravitational potential at the end plus the work done against the resistive force. And in this case, the mass of the object will play a part. When resistive force is taken into account, the height at which the ball reaches is actually dependent on the mass. So you have to consider the mass in the equation. I advise you to go look at some practice questions in order to help reinforce what you've learned today. It's a good way to understand how to apply the content and the equations. Please make sure to subscribe, like and comment, and feel free to watch any of my other videos if that will help you with your physics course, and good luck for your future.